active, I would say, thought leader. He contributes to a lot of open source project as well, and he's quite adventurous in whatever he's doing. So he's going to share with us some of his experiences in terms of generative AI, and specifically about spec-driven development. So for people who are new to spec-driven development, spec-driven development is I would say it's a framework wherein it helps um, use the generative AI in a seamless way. Um, so that's the. I'm not going to reveal anything. I think Shiv has a lot of to cover. With that, I'll probably hand it over to Shiv.
Thank you very much. I appreciate that, and thank you, Prem, for giving us a forum to have these kinds of conversations. So I appreciate that again, to welcome me to this community and then give me the opportunity. I'm excited to share what I've been doing with AI, and sort of there's a lot of conversation, things around AI. We keep inventing new terminology, new words to mean old things, and you will see that maybe I'm not like exactly conformant with what the industry calls spec-driven development at this moment. And there's things like spec kits and so on and so forth. The way I think about it is, how do we scale? AI exists. We are all dealing with AI in our work environments, and we have different levels of access. I work at Microsoft, so I have, unfortunately or fortunately, unlimited amounts of AI. With it comes unlimited expectation on using AI to scale oneself and scale how we operate in our industry. And I've been through a couple of transitions like this in this industry for over 25 years now. And me and Prem, for example, we met about 20 years ago. That was the time when the world was going through a Web 2.0 transformation. And we saw a lot of churn come through because of that. And similarly, now we have AI that's changing how we operate. And I've been doing so for about the last 1 year. And especially in the last 3 to 4 months, things have really accelerated. And this presentation is to sort of capture some of the learnings of the last 3 to 6 months. Right? So it's not going to be very technical. If you're a technical person, you might not get as much out of it. But if you're a product manager, or if you're a manager of some kind, or if you're a business leader, or running an organization, perhaps you can take some of the learnings and apply it to your own organization. So with that, I'll start the share. Are you able to see it? Am I hiding something? I can turn myself off if that's...
I think for now it looks okay.
For now it's okay. Otherwise, I'll just bend down a little bit more. Okay, cool. All right, so this is just my little session to explain a few things. Just to set some context, I'm a product manager at Microsoft. Besides that, I'm also a bit of a code monkey. I've been programming since I was 13. And so I continue to have personal projects. And of course, since I moved to product management, I haven't really written a lot of code. You can see in 2024, I made 17 contributions to my open source repositories. And you can see how in 2026, with the advent of AI, and me having more access to AI, I've contributed a lot more. So you can see 2 boxes here. The second box is the amount of code I'm writing at work, which is kind of insane given that I had chosen to not write code, and that's why I moved into product management, but now I'm writing more code than ever before. What that means is I have a lot of repositories, a lot of projects that are going in parallel, and there's a lot of context across those projects that's very hard to keep track of. So that sort of drove some mental model shift for me on how do I manage my own work across multiple repositories. How do I capture valuable context and then transfer that across the work context that I operate in. Sometimes I do personal work, sometimes I do work for Microsoft, sometimes I do some research work. So how do I move the context across that, and how do I keep that in sync? And then of course at work, how do you not just accelerate yourself, but also accelerate the set of teams you're working on? How do you organize, and how do we instruct not just my own agents that are running to do my work, but also help the agents of other people that are working with me and drive overall end-to-end velocity. So that's the sort of journey I've been through for the last 6 months, and this is a little sort of summary of that. So when I talk about AI, I think about it in these dimensions. We want to scale our own individual velocity up. We want to use the fact that you have very quick ability to try things out and prototype to do more experiments, so scaling out. And we want to also scale across peoples and teams, and you want to scale through time, right? So as you run a project or multiple projects, you want to accrue benefits and you want to compound those gains as we walk through them. And writing specs really, and what we're going to see today is writing in general and writing in a very particular way, and storing information over the course of time and in multiple repositories and organizing them is how we scale. Right? So that's sort of the thesis. As an example of scaling up, I wanted to sort of show a couple of projects that I'm working on. This is just for my own personal interest. So I have this need. I want to have an LLM router that has built-in memory management that can then synchronize and keep my memory across multiple projects in sync. So I came up with a project called Faraday, which I'm trying to build. And as I was building that project, I realized, well, it's, I need a few base components that are different, that are not traditional ways of organizing information in order to get the extra leverage. So I needed a database that was like more purposefully designed for storing memory information. And then that meant I need some way to instruct that database. And I could use SQL and just follow the existing vector DB methodologies. But then you don't get the extra leverage that you would if you had a custom one. In the past, I wouldn't attempt a project like this, but now that I have AI, I can, as a single person, think about writing a language, using that language to drive a database, using that database to drive some external project that I'm doing. I wanted to use this example because in this case, I'm able to instruct the AI for each of these projects, and I'm able to feed the spec of one of these projects into the other. And then in each case, it's a different thing that's a spec. But you get to operate and scale across from one project to the other by feeding the input and output to the next phase, right? So you can scale in ways that you couldn't really do something like this before. It would take you an army of engineers and probably 6 to 8 months before you even get the first iteration. But now you can do it in an afternoon. So later I will show a quick demo, and maybe we'll see if it works. I have this language. I needed to add 3 constructs, and we'll see if we can add that live. So this, I call this scaling up because as an individual, you can scale and work across multiple projects. Then the other one is scaling out. So you might have multiple ideas that you're trying to work on. We'll see an example of this in a second. And this I do using Git work trees. So if you're familiar with Git work trees, it allows you to have multiple copies or multiple branches all available at the same time in your local repository, and you can try multiple different ideas before you merge those ideas into your main tree. Claude works really, really well with Git work trees, and this is a way for you to scale out. Like if you have one project and you're trying to try 4 or 5 different things before you pick one of those options, then it's a great approach for experimentation. And let's see. Okay, so let's see a quick demo of this one. So I have previously saw the Sodal language. I want to add the alias concept. I want to add constant concepts and discriminated unions. I've already defined that in the proposal doc, and then I will just let Claude run through my definition and iterate on those changes. Right. So let's see if I can.
Shiv, probably for the benefit of all, do you want to probably talk more about what Sodal does?
Oh, sure. Yeah, like let me try.
Context.
Yeah, to set some context for sure. Let me pull up my. Yeah, so in this case, it's just a custom little language that I invented just so we can organize information. So let me pick up maybe an example and show you. Okay. All right. So let's maybe before we do this, let's go back to why you need Solo. So I want to build a database, and that database, unlike say a SQL database, or it's more like a graphical database, right? And but it's a multi-dimensional graphical database, which means you can define the structure in arbitrary ways, and then you can store based on whatever set of structures you define. And this is very useful when you're trying to do vector DB type of operations. And I'm trying to build something. All of the existing vector DB solutions are remote solutions, right? So you can have some centralized database and you can push data to it. There aren't very many on your device local like SQLite equivalents. So I'm building Silica DB to do that. But in order to do that, you need some schema language to inform this database, right? So I could use Avro, for example. But while we're at it, we can also define a language that's custom defined, custom suited for what we're trying to do. So Sortle allows me to do that. So for example, I'll just show an example Sortle file. So let's say Sortle has its own special constructs. It's very similar to C, but it has additional concepts. It has concepts like keys, right? So you can define a struct called address, or maybe let me pick something more real. Okay, so let's see if you have key map preferences. Okay, let's take this one. So you have an object called preferences, user preferences, and then you might have a preferences key object, and you can define how that key maps to that object, right? So this construct, it's not existing in any language. I get to define that language, and then that can have its own custom meaning. Like, so for example, you can have a primary key, you can have a secondary key, you can have any number of keys, and then that makes key lookups much more efficient. Why that's useful? Well, when you try to retrieve memory, you want to have multiple ways of addressing the same fact. So having constructs like that will allow us to build an LLM memory manager that's more efficient, right? So now in this language, I want to add some new constructs because I want to add constants. I don't support constants right now. And I also want to add a couple more features. And that's what we'll be looking at. Did that make sense? Any questions, Prem? Like maybe, was that clear enough?
That's good. That's good. Thank
Okay.
you.
So, but it's not very important what this language is. What I wanted to show is how easy it is to work with Claude and work trees and sort of do complicated things like this, right? Okay, so let's take that. So actually, before we go, I wrote a proposal just for the demo. Normally, I wouldn't sort of have phase difference between that. I would write the proposal and then I would immediately try it. But here, so as an example of a spec, there's a lot of context already in this project. It already has the Sortle specification, so it can understand that. My Claude MD will tell it to go read those Sortle specifications before it adds things. And then I have some rules, like, okay, if you have a proposal, how do you convert the proposal into updating the specification and writing the examples and so on and so forth. So I would write a proposal like this. I'd say, okay, I want to have something called alias. This is a good example. This is what it should match. What is the motivation? Here's some open questions to answer. And then likewise, right? So for name literal, do this. For discriminated union, do this. So by writing in detail what I wanted to do and what kind of questions I wanted to ask and answer, I can direct the AI to be very, very narrowly focused in what it's trying to generate, right? So that's the point. This is one example of writing a spec. It doesn't have to be in the traditional sense a feature with a bunch of ICANN statements. It can be more RFC style, right? So it's Claude is very good at understanding those because it knows it's trying to build up a language. It can sort of, as long as what you're specifying is very clear, then it can pick up that and operate. So now what we're going to do, what I've already set up the system to do, is I'm going to launch separate work trees, and then I can have it run. Hopefully this works, eh? So I can have it run in multiple different things. So now I have 3 different language constructs that it's working through, and then it's going to find the grammar, it's going to find the spec, it's going to write examples, and then I can operate in different time scales in different branches, and then you can then choose to, like, it's much like I can now go away, come back another 5-10 minutes later, more things will be ready, and then I can start working on this. This is another way to scale. If you really get used to working with work trees and using Claude and writing specs to drive that, your life becomes much simpler. You can scale much faster, right? I will let it churn through. It's going to take a second. The other thing, the LLMs are getting to a place where when you give it more and more complicated tasks, it can run for longer and longer. So thinking bigger, writing things like this becomes more and more feasible, right?
Hey, Shiva, one
Yeah.
question, if I can ask. Srini here.
Yeah.
I missed the point of where did you define in spec to try 3 different things in 3 different work stream? Was it in?
Yeah. So it requires a few things to set up. That's a really good one. Of course, this is open source, so people can come and see this later. So maybe this is a good opportunity for us to talk through set of things that I normally have when I'm building complicated things, right? So in this case, I'm building a language. So when you're building language, there are 2 concepts, right? There is the general purpose description of a feature, which we would typically put in something called a primer. It's trying to explain, okay, what is a struct? What are the different features of this language? So this is meant for human beings to read and understand. And then there is normative definitions, right? So normative definitions are like sort of technical ways of very clearly specifying what a thing is. So if you look at Avro specification or Parquet specification, they'll have the same sort of things. They'll have a spec, which is normative, and they'll have a primer that explains how to use a feature, right? So writing in that style, because Claude and these AI systems have understood lots and lots of RFCs, lots and lots of these language definitions, they're very good at this. So if you can write in the same style, then it's able to pick up very precisely, right? Especially for things like language definition. So I have 2 things here, primer and specification. What I want to do is have it write those, right? Because it's very difficult to write this. I can write it, but it'll take me months. So what I do is I write something called proposals. And in the proposal, it's somewhat more loosely defined. And then I'll allow it to then go and write the normative definition, right? So to answer your question, Srini, I put it into these proposal documents, and then I say, this is the example, this is the motivation, these are some questions I have, these are some questions we need to answer, and then it'll pick that up and churn through. And sometimes it'll ask me questions on what do you want to do, this conflicts with that thing, should we deal with that? But other times it'll just make some assumptions, tell me this is what I made, maybe it's done, I can show you. And then this is a way for us to build the language up. Right? Did that answer your question?
Yeah, thanks.
Shiva, I have a follow-up question. So from a definition perspective, I know there are standards that are evolving about the spec.
Yeah.
But let's assume that I write the spec for, say, Claude.
Yeah.
How easy is it to interoperate or import it to, say, GitHub Copilot or ChatGPT?
That's a really good question, because like I have a slide later that says like the language models don't matter anymore because they're all equally good, right? And like we have all these coding benchmarks, right?
Mm-hmm.
See all these numbers, and that's marketing around which they now this Claude is now number 1, and they open whatever, whichever one is better. I find that those distinctions matter less and less, right? Yes, Fable is a step more in the sense that if you're building something simple and non-novel, right, it's very good. But if you're building something novel, none of these models really make that much of a difference. They're all about the same because you have to do the work, right? You have to be clear. Like, for example, I'm writing a completely new language. None of these models make a difference in terms of like, should I have an alias, right? That's a choice that a human has to make. And you still need, and it can give you suggestions and things like this. It can and oftentimes it'll go bad, and I might have a stylistic way of representing it. So it's still a lot more human-driven input. So the influence of the model makes a lot of sense if you're building a traditional app or you're building maybe a mobile app, because there's so many patterns of that existing, right? So in those cases, the models will improve. But for really novel places, it's the utility of which model is less, but then having a decent enough model, like something from the last 3 months, that's that's huge, right? Like, but that said, there is a difference between using Sonnet and Opus, right? That's where the gap was. Once we cross the Sonnet milestone and everything's around the Opus levels, not that much difference, right? At least that's my personal experience. And then again, difference between GitHub Copilot particularly and Claude Code and those kind of which agent you use. That's just a fun. Like I use Claude at home and I use GitHub Copilot at work. And GitHub Copilot, incidentally, also understands Cloud.md. So as long as I have a Cloud.md, that context ports over. So I've just settled on Cloud.md. But there are other ways to normalize, right? So if you prefer a different one, then you need to make sure that those instruction files make sure that it can accommodate for the other ones,
Yeah.
right?
I think Shiva, so it'll work seamlessly if the same spec is given to other harness plus model, right? Beat Codex, GitHub Code. But one question building on to what Prem said, right? So spec, there are some definitions exist.
Yeah.
Standards exist, not definition. Standards exist, right? What is evolving? Is there a standard evolving around this? Is there an industry accepted spec definition?
I mean, I wouldn't say industry accepted yet. Everybody's competing for that space, and lots of people are writing things, right? My general thesis is if you have written specs for human beings before, and if you have done a good job at writing functional specs before, simply following that structured approach is just as good as any of these other ones, right? But yes, the standards will come. People will have, like, for good reason, give people structure on how to write a spec, right? But the good thing with the LLMs is that they don't need that much structure.
Yeah.
They understand meaning. So the point is to not constrain yourself to some structure, because that's not going to get you the outcome. What gets you the outcome is how clear you are, right? That gets you the outcome.
Yeah, right.
And the structure will help you with that, right? So, not everybody is used to
Yeah.
writing technical specs. Not everybody can write an RFC. So from that perspective, you can pick any of those standards. Like if you like writing RFCs and that's the standard you want to adopt, works great. Like you can, I haven't done this experiment because I don't want to waste my time doing it, but I suspect if you take the TCP RFC and make it implement a TCP server, it will be able to, right?
Yeah.
It's all like, I know it's done that. Actually, I will show the project I'm working on. So we're working on getting this spec ratified. It's called the X registry spec. It doesn't matter what this particular spec is about. If I give it this repository, I don't even have to give it to the spec. I just give it this repository, and then I ask it about concepts in this spec. It can immediately understand the abstractions, right? And so this spec is written as per the RFC style, right?
Mm-hmm.
IETF spec or whatever, right? And so you can, yeah. So it'll be like it's very similar to the other doc I showed you. It's very normative definitions. What is a schema group? What is schema? Blah blah blah. Give some examples. So this,
the specification is just a template to ensure its completeness. Otherwise, it's okay. Yeah. Okay.
Then the key I want people to take away is pick a spec that's good for the domain, right? If you're writing a web app, right, don't write an RFC. But if you're writing a language, again, don't use the traditional spec, right? If you're writing a language, it's seen a lot of language specs. So you need to conform to that spec, right? So for example, for SilicaDB, I'll write like ICANN statements, right? Because that's just software. That's a database server. Whereas for Sordal, I have to write in how people define languages, right? And so that's the adaptation we have to make. But even if you don't, it still does a pretty decent job. The point is write your features down in a very clear way. And later on, I have some example of what you want to include or not include when you're writing general purpose software. Yeah, so we'll talk about that in a second. Okay, let's see if in the meantime it did anything with that. All right, so now you have 3 sessions. It's going to ask me questions. Now I can operate on each of them separately. Let's see if this works. This would be interesting to show. I have a little program called Nodum. What this lets me do is, maybe not. Maybe it's not showing me here. This is supposed to show me all the Claude Code sessions. Oh yeah, it's there. Okay, so it's detected that I have 3 sessions. I can see all the transcripts, all the files, all the history. If I initiate subagents, I can see those. So there's a lot of context that's happening, and I can work on this over many days if I needed to, right? And you can sort of see when it's going out of cache and then bring it back. So the general idea is having work trees, having good specifications, allow you to scale and work on multiple complicated concepts at the same time in one repo, right? Okay. Now let's come back. Okay. Any other questions before I move on? Okay. So that's the example for the work trees. Okay. So now let's talk about sort of scaling across. So to set some context here, I work in the Azure messaging business in Microsoft, and as I mentioned just a few seconds before, I'm building this schema specification, and we're trying to implement that in the product. That means I have to work with many teams. I have 4 different engineering teams that I have to work with. We have a designer who's going to design all of the schema-based interactions, and we have another additional PM that owns the underlying feature on which you're overlaying the schemas. So I have to work with that person. So we're writing specs, and we are using those specs to drive the projects. But we definitely face challenges where, like, how do we share this information across the team, right? Previously, you would write the spec, somebody would review a Word document, they will go off and start their work. But that's not how people are working today. Everybody's running their own agents. The other PM is adding features. I'm adding features. We are adding research, customer research. We have lots of meetings. We have to transcribe those meetings. We have action items from those meetings to address in the specs. People have to review these specs. We have to then, over time, iterate over the specs and deliver code, right? So the way we've organized ourselves to communicate, and this is the idea of scaling across, is we have a common team repo. We have multiple, in a second, or maybe I should have shown that part before this. So we have, it's very simple. It's just a set of markdown files. We have specs in a folder. We have episodic memory. All the transcripts are translated and put into the episodic memory. We have glossary of terms. So we have a place where we define all the jargon that we're going to use in the product. And that's very useful. If you're able to define different concepts, and you can use those concepts in your specs and build up sort of the complexity. Let's say, I have this idea of an event schema set. So I will define what a schema set is, and then I can use event schema set elsewhere in my specs, and it'll understand what that is, right? So building up that glossary of terms over time, and sort of talking about components, talking about different parts of your product, that's very useful. And then we have that all in the team repo, and then we use Git submodules. It's very simple and straightforward. Each of us have our own repo, and then we have the team repo as a submodule, and that's kind of how we cross-collaborate. And we have a process around this that allows us to all stay in sync, and then each of us can sort of run our own agents from that common place. And I think it's pretty obvious. I don't know if that's what other people are doing, but this works really, really well for us. Does anybody else have this experience of sharing specs and content to drive other people's repos in the call?
Yeah, we do that. Sure.
So how do you share how do you keep those things in sync?
Yeah, that's the question I was about to ask, because the challenge is not necessarily with the dev teams, but when it comes to QA teams, the QA teams, the common methodology of sharing the design docs tuned to the cloud is what we are using. But the challenge when QA team gets it is, unless otherwise we define certain constraints, they end up having a lot of test cases that essentially complicates things, right? Because
I should just give this a shot. I think so one thing we said was we're going to ban any other way of writing specs, whether it's dev design or even just functional specification or design definitions or test plans. None of those things happen outside the team spec repo. So that's the basic rule, right? It's everything's marked down, everything's in this team spec repo, and there's a folder. And then as work progresses, people get to do pull requests, and anyone can review that pull request and merge that in. If it's not merged in, you can't use it. So that's just a general consensus we've built, and then we have the standard places to put things. Right? It's as simple as that, and then that creates just this automatic method of sharing, right? Because when a developer is writing code and a tester, the test partner is trying to build tests for that, they won't accept your code if it's not if they don't have a corresponding spec in the repo, right? And it's just happening naturally. We're not trying to mandate or anything like that, because people find so much value when you have like the test plan there, and the PM can look at it and approve it, or can call out like, hey, you're missing this particular case. It just makes because everything is in Markdown, because everything goes through the same review process, it's fully transparent. If you can organize yourself like that. But I'm not saying it's easy to do across large orgs, but with small groups.
Yeah, the challenge is moving the teams from the conventional non style to that of AI style, right? So
no, but I think the value is are all your other teams also using AI to generate, like, say, test cases and stuff like that? Or?
We are moving towards that, but then the initial challenge what we have is, even though you have a spec or a mini spec,
yeah,
the system doesn't know how much of test case or test plans it has to generate. There's a lot of test case sprawl,
yeah,
when we need to go and control it, right? You see what I'm saying?
yeah, absolutely. And I think like there is that's the other thing. Like if you leave, that's another thing you can control using the spec. There's multiple dimensions to writing that spec, and I think that has to change now, right? So writing a functional, it used to be like for functional spec, you only talked about the positive scenarios and what functionality you want, right? But now the functional spec and the design spec and the test spec, it's all sort of one spec really. And it's we all have to maybe people are contributing different sections as opposed to writing different specs, right? And driving constraints, and the way we break the work down is changing, right? It's like you can truly have this kind of like vertical slice that gets executed, and then you build another concept and you execute that, right? Unfortunately, I can't show you the actual spec because we are executing on this right now, and it's proprietary content. So
yeah, one question.
Yeah.
You are Prem.
Yeah.
So how does this project management and this comes in? Say, for example, in Agile world, we've been defining user story, break that down into task, right? And moving on, right? So how does that mirrored here?
I have an answer, but Prem, go for it. You're the manager.
The interesting part is we challenge Claude, because Claude comes back and says that it takes, say, X number of stories, Y number of time, right? But then we ask it, okay, churn it. That's how it is. But to answer to your question, there is as such no major change in terms of project management. The style remains the same. The only difference is in terms of estimation, right? If you look at the conventional agile world, each user story has the story points, and then the developers all join together, and then they estimate, right? But 8-day work or a 10-day work becomes like a half a day work or less than that in terms of code generation. Okay? So predominant effort goes in terms of validating it and testing it, right? Because we are still in a very early stage to get into completely a test-driven development or a test automated form, right? So that is where the effort, to answer to your question, dev is shrinking their timeline, whereas the QA sort of wants to ensure that it. So that's it. Yeah.
Especially any sort of end-to-end QA, or if you have any sort of long-running process where like you gotta wait for a 2-day build and then you have to do the end-to-end testing, your bottlenecks got way worse, right? So they got 10x worse. This is definitely an issue. Like I'll give you our own example. So I work in Microsoft Fabric. Our builds until actually this cycle our daily builds took us 3 days to build, right? as many of you might know. That's but now it's like we can do 2 per day, right? So one of the things we did in the last 2-3 months is prioritize that and say, okay, we can't accelerate if our daily builds are going to take 3 days, right? So some of it is investment, and you have to fix some of those things. But now we can build features very quickly, but you can't take it to prod, because taking it to prod takes 8 weeks, right? And so you have to do a lot of soak testing. And previously, 8 weeks was enough to test the 3 features you're going to build. But now you can build 30 features. So now, so we have different constraints now, right? And so all of those challenges exist, and people are trying to innovate around that, right? Like we're trying to be now. It's fairly straightforward to if you have like what is that where you can have like the UI-based click testing, like that Claude
Mm.
people
Mm.
are doing that. I mean, of course, you have unlimited tokens, everything becomes simpler, right?
Yeah.
I'm not saying it's applicable in every environment, and people are experimenting, right? Even there, they're like, okay, how long can you do this kind of click-based testing? Can we improve? Can we partition things in a different way? People are starting to design things differently, so it's the testable boundary changes, right?
Mm.
So that I think
I
that's where
think the power of the system comes in when you automate even the test cases, right? So that the feedback loop that's established, right?
Yeah.
Of course, you can also use Claude to create a sandbox with the right set of environment.
Yeah.
You don't, I mean, you cannot trust it until you see it working and then you run through all
But
of it. Right?
with Playwright, you can, like, I mean, if you have a UI-driven product, with Playwright, you can do a lot already, right?
Mhm.
And so most of our like sort of flow testing, like, we have this kind of a lot of flows in the product where you click through 5 steps, and then there's many flows within that 5 steps, and then you click finish, and then something happens, right? So a lot of that kind of testing, it's pretty standard design, so you can build tests around that, and you can use AI to generate those tests, and you can run them on known good builds and validate them, and then sort of
Actually, the challenge for us is it's not a UI. Ours is more like towards the radio.
Mm-hmm.
You have a hardware that you are dependent on.
And
then that's where the last mile of testing it comes into
right.
charge.
And so, like, yeah, of course, like not everything's gonna benefit from this, right? Like at some point you'll hit physics, and then as long as you stay in computer science, you're okay. Once you hit physics, then things
And we are creating simulators so that we can simulate the real life, so that you can get all of your integration testing and even feature testing to a level. And then when it comes to real life testing or deployment testing, you go for the
absolutely, absolutely. So just to come back, like the what the spec can allow you to do is kind of operate across multiple teams, but then we still have definitely the challenges the backend remain, right? So we can accelerate all the way up to dev, right? Run a lot of experiments, but that's, as we talked about, that's where the gate is, right? This in the last 6 months there was another interesting thing. It just kind of happened naturally, and I thought that was an interesting just byproduct of us putting all of these things in a Git repo and tracking it, and getting the team behind inventing some process around writing both both the feature, but also starting to write contracts and design engineering design in the same repos, right? Because what it allowed us to do was for the new feature, the engineering team built some engineering design on how the different component APIs need to change, right? But that also drove interaction design, because that told us what we can and cannot do from the UI. So then I was able to overlay on top of that after 1 or 2 months of making the underlying system work. I defined just using specs what each UI workflow should look like. Right? Now that UI workflow spec, our designer, instead of actually what he would normally do is take a spec or have a conversation and then go do some Figma designs, come back and give it to the team. But instead, what he did this time was he took the UI click stops and the larger spec, and he, instead of building Figma, he just did a whole prototype of the entire product. So what we ended up with is actually working software that's a prototype software built from the specs, which then fed our evals. Like that meant that the engineers, they didn't need to go look at the spec to know what to implement. They can look at working code and go, okay, I click through these things, this is what needs to happen, this is what the backend calls should look like based on those workflows, and then based on that they're able to go build, right? So it's kind of like you don't, while you use the spec to drive the AI, you can also use the spec to drive understanding, right? Because And we found so many things in the UI workflows that we need to fix even before we wrote a single line of production code, right? And we were able to find and fix the backend APIs before we even started the project, right? And so the other advantage of writing specs is that as you iterate on those specs with your team, over time you will get this benefit, right? So over time you will find things earlier in the cycle before you even generate code, right? Or before you even write your first production change. So that's, I call that scaling through time, but not necessarily scaling, but it's a nice side effect when you start actually writing specs and tracking your work diligently. Right? So let's see.
In fact, one of the advantage I saw, Shiv, is that having defined the spec, right, the system gets into a guardrail type of environment. It doesn't really hallucinate much because
Exactly.
it actually knows what it needs, what is the end goal, aspects like that. Right? So yeah.
It's not, that's excellent. Great transition to our next step. So I took a little screenshot because I can show you the contents of these things, but I can show you what these things are. For example, when I started this whole project, I wrote just that concept stock, right? So there's polymorphic streams concepts. I wrote a concept stock. That was like 6 months ago. And then from that, we started slowly writing all the different specifications. There's a functional specification, then there's lots of different specs that some of these, I mean, they're not very well named, but some of these are for engineering design changes, like this baseline URI spec change is an engineering change. The endpoint spec is how we wanted to represent this thing called endpoints in our system. Then we had like certain complex rule processing that we have to do. There's this concept called protocol options. So we did some design work there. So those were captured. And then we did all this UX work, right? So we did all these click stops, which are dividing up all the different UX changes that we need to make. Each of these specs, the idea is not just what you want to do, it also defines what done looks like, right? So we have sections that say, this is what it means to pass this particular workflow or fail this workflow. We have different phases, so it's not over implementing, right? We have like phase 1, 2, 3, 4. So we pick different sections in the spec and say, this one you implement in phase 1, this one in phase 2, and so on and so forth. So when we generate stuff, it will stop at phase 1. Right? We can say, okay, in this iteration, we're only working on phase 1. So it will not try to implement the phase 2, right? So you can constrain it while keeping this spec progressing. And you want to introduce concrete examples, you want to build a glossary, you want to build abstraction, right? So you don't want to re-describe the problem every single time. You want to say, okay, it's this problem, and if it's this problem, then these are the kind of solutions, and you write your spec in that form. Like for example, with this particular feature we're building, one of the things we have to do is how do you associate schemas to different input and output sources and destinations, right? So that way you can say which source will send which schema and which destination will get which schema. So I wrote a little like a concept around schema association, and then have some rule definitions and say how should we represent that in the backend, how we should represent it in the UI, and sort of you build that concept of schema association, and then you can use schema association elsewhere in your doc, and it has a very concrete view of what that means, right? Of course, it helps that all of this work is based on that schema registry spec, and that's a very well-defined spec. So we can always lean, anytime we have to do something complicated, we can lean on that spec, right? But that said, for your own domain, for your own project, you can sort of start with building those concepts up. And as you build the complexity and clarity up, the more control you have over what the output's going to look like, right? And of course, when developers are implementing that, like I've had many developers, we have like about 3 different people implementing different click stops. One person is focused on the sources, another one in terms of the operators, another one in terms of the outputs. And then so they can all like take each of those specs, each of the sections of those specs, and then use it to feed their agents to generate their code and start building the software that they're building, right? So the most important thing is you can't just describe what you want, you have to describe the context and why you want it. Just like for human beings, it's super important to set up some rules. And by describing why you want something, you're actually defining the boundary and the rules, right? So writing that well is super important. And the other one is, as a ex-AWS PM, I find this very challenging to say. Like writing in bullet points actually works better. Writing in narrative form doesn't work as well. So, which is the opposite of what I used to do at AWS, but that does work. And surprisingly, ICANN statements work really, really well. So if you enumerate all of your small behavioral items as ICANN statements, just like you would write user stories, and that works very well. And if you write it in the same style, and with what done looks like, that also works really well. And then it's very useful to also say, these are areas I don't want to solve right now. Right? These are areas we're not solving, we're differing, or undecided. So it has a section where it can add more things when it finds more undecided things. But also, it cannot touch those areas. Right? You can say, okay, if you don't have to decide that, park it in that area, and then you can keep iterating over time. Okay, I'll stop there. I'll have a couple of, maybe there's an example here. Oh, maybe not. No, I don't have quite an example for you today, but if there is interest, I can share. I can try to take one of my examples and convert it and share later. Okay. So in addition to that, as I mentioned before, I just wanted to throw this last bit out. I'm tracking about like 7 or 8 projects across the three or four different work streams. And it's very challenging for me to track it. So what I did, and everybody should try this, if you're working in a multi-project environment, if you're tracking work in Jira or wherever else you track, we have a different internal tool. Build yourself a chief of staff skill. And this is one of the most useful skills, because once you build a repository like this, once you have your work tracked in the repository, like what you're trying to achieve tracked in the repository, if you can connect your operational tools into your agent workflow, you can build an agent skill. Like I went on vacation for a week. I came back and this is literally my prompt. I just said, I came back from vacation. I need to understand what happened. Can you help? And then just by looking at my spec repo, it was able to figure out what the 3 trains of execution are for July, because I have my planning also in here. And then it went and found all of my, in our system, we have something called ADO, where we track all the different user stories, and people, when they commit PRs, it gets tagged against those user stories and so on and so forth. The result of that was I had a one-pager that showed me all the commits that were made, who made those commits, when were they done, what's being blocked, what's being delayed, which build it'll come in, like where I can go help, and so on and so forth, right? And this is like sort of a complete side benefit of defining your project in specs and doing planning with those specs, is you can do operational management with that specs too, right? It's not quite like spec-driven development, but those are the side effects when you fully hand over your entire workflow to it, right? It does, this one takes a lot of energy, but if it's possible in your ecosystem, if you have people actually using the tools to ask questions or flag things that are blocked and things like that, if you have that kind of an operational system, I'm not saying it's perfect. Sometimes it will be, I have some teams who refuse to put anything into ADO, other teams who put things into ADO. But you know, when it is there, it's useful to build. Okay. All right. So in summary, you should build specs for your own work so you can scale with your own agents, but you should also figure out how you can convince your teams to share that knowledge across your teams, because that's where the real multiplication comes in. When they start feeding back into your specs and you drive their work through your specs, that's where you get the efficiency. It's not, now the loop terminology has been taken over, but for me, that's the local and global loop. And today we just discussed these dimensions. So we discussed how do you scale across people, across agents, across time, and across task horizon. But there are other dimensions which I haven't explored. I'm hoping maybe somebody else in this group will come and tell us how they can scale for verification, or how they can do long loop autonomy, like autonomous tasks. I'm experimenting with those, not quite there yet. And I think the gateway to that is still being able to specify what we want out of the system more clearly. So just some 5 habits to wrap up. Ignore the tooling, just focus on clarity, focus on writing long-term persistent docs that then you use to, instead of driving prompts, so that you can use that as a compounding mechanism. Start, just like humans, you have to start with the vision, then set the goals, then set the tasks, because it's so easy to start at the task level. Then you really can't, then that's where we go sort of hallucinating in different directions. You end up with too much code and then you can't deal with what's happening. Next time you start a project, start top down again, and you will find that you start with the constraint boundary, then you can get to and done state much easier. Build abstractions in your documents. So you have just like if you've worked with a 100% team or a 20% team, if you don't build concepts and vocabulary around those concepts and some jargon, you can't scale your communications, right? So it's the same for the agents too. And then this is something I do. What I do is every so often I would go and rewrite a doc, right? So there's a lot of generated code, and it's going to be a little bit, it won't be precise. So it's useful to read through and then edit your specification for your project down. And then every time you have new things, you do have to like sort of revise, right? So that's where the value accrues. And Scott Hanselman is one of my favorite VPs at Microsoft. And I'll leave you with that. He said, in the future, the programming language that we will use is clarity, right? And it doesn't matter what language we actually generate to write the code. It's going to be how well we can define the problem, right? So I'll stop there. I'll take any questions. Oh, we are at the hour, so I'll take questions or leave it open for a chat.
Let's open up for questions. Any questions from attendees? If not, thanks a lot, Shiva. This is great because one thing is as we mature in this AI-based code development or vibe coding, such guidelines really helps. And then I felt the session really gave a step-by-step approach to how to write a spec and then how do we benefit out of the spec-driven development. Thanks so much.
Appreciate it.
The more sessions from you.
Yeah, if folks are interested, I'm happy to share the deck. I'll upload it shortly. And
Sure.
Then, and then if you want links to any of the repos, I'm happy to share those too.
Awesome.
Awesome.
Thank you so much. Bye for now. Thank you. Thanks, everyone.